Week 6. Today we're going to be focusing on rearranging formulae, long division and surds and indices. So it will be split into 3 sections. Okay, so we're going to be looking at rearranging formulae first. So I'm going to start with the first example here. Now the first example is going to be express 3a minus b is equal to 2c in terms of A. So with that type of equation or type of question, you want to isolate A. Okay, so you want to get A on its own. So what we do first, I'm going to rewrite the equation. So 3a minus b is equal to 2c. So I'm going to isolate 3a because that's where the a is. So I'm going to isolate 3a. So in order to do that, I want 3a to be on one side of the equation, which means I'm going to need to bring minus b over to this side of the equation. So it's now going to become 3a is equal to 2c plus b. Because when we cross an equal sign, it changes. So it changes to a plus. So now we have 3a on its own, so we have it there on its own, so we need to get a on its own now, which means we need to get rid of the 3. In order to get rid of the 3, we need to bring it under the equal sign, so a is equal to 2c plus b divided by 3. You've now solved the equation because you have a on its own. So when it's asking to express it in terms of a, that means you want to get a on one side of the equation on its own. So we're going to do 2 more examples now. We're going to go to example 2. So example 2 is express 2 bracket x minus y is equal to z in terms of x. So you want to express it in terms of x. So what we need to do first of all is get rid of the brackets. So we're going to multiply out the brackets here. So we have 2x minus y is equal to z. So 2 by x gives you 2x, 2 by minus y gives you minus 2y is equal to z. So remember, we want to isolate x, so we want to get x on its own. So let's get x on its own with the 2x first. We want to isolate this on its own, which means we're going to need to bring the minus 2y over beside the z. So now it's going to be 2x is equal to z plus 2y, because the minus, when it crosses the equal sign, it becomes a plus. So 2x is equal to z plus 2y. So I've just written that out again. Now what we want to do, we want to get x on its own. We don't want 2x, we want x. So we need to bring the 2 over here to this side of the equation. So when we bring 2 under the equal sign, it's going to become z plus 2y divided by 2. So x is equal to z plus 2y divided by 2. And that's it. So that's x isolated on its own. So we'll go to example 3 now on the next slide. So now we're going to go on to example 3. It's the same style of question again. So this time it's express p plus q over 3 is equal to r in terms of q. So this time we want to isolate q on its own. Now, the easiest thing to do here is to get rid of the fraction. So what we have is p plus q over 3 is equal to r. So let's get rid of the fraction by bringing the 3 over here. Now, 3 is being divided on one side, so when we bring it over to the other side, it's going to be multiplied. So what we're going to get is p plus q is equal to 3r. So now, what we need to do, it's asked us to get it in terms of q. So we want to get q on its own. So we want to isolate this on its own, leave it on that side of the equation, which means we need to bring the p over here. So we don't see a sign in front of p, so we assume it's positive. So when it crosses over the equal sign, it's going to become negative. So what you're going to end up with is q is equal to 3 or minus p. And that's your answer. So we're going to go on to the second section now, which is long division in algebra. So we're going to do a couple of examples in that now as well. So a typical question you get here, and this is going to be example 1 from this. So example 1, and you will be asked to divide x squared plus 5x plus 6 by x plus 2 using long division. So it is specified there that it wants you to use long division. So the way we're going to do this, we'll write it out first of all the way it should be written out. So x plus 2, you're dividing that in to x squared plus 5x plus 6. So what we need to do is divide x into x squared. That's the way we start this. So we're going to divide x into x squared. Now, if you're not sure how to do this, what I would do is put x squared like this. So x squared is x by x divided by x. They cancel and you're left with x. So that's the answer. So here, x into x squared goes x times up here. So we're going to put x up there. What we need to do next is multiply x by x and then 2 by x. So x by x gives you x squared, so I'm going to put it down here. And 2 by x gives you 2x. Now, the rule is here, we need to change the sign. So we need to change the sign of this and this. So we assume that this is positive, so we change the sign to negative. This sign is positive, so we're going to change it to negative. So now what we're going to do, x squared minus x squared cancel, and what you're left with is 5x minus 2x is 3x. Our next step is you're going to bring down the 6, so it's 3x plus 6. What you're going to do at this point is you're going to go again, so you're going to divide x into 3x, and I'll just do that over here. So 3x divided by x, they cancel, gives you 3, and it's a plus 3. So you're going to put plus 3 up here. Then what you're going to do, again, is multiply x by 3 and 2 by 3. So x by 3 gives you 3x, and 2 by 3 gives you 6. So what we need to do now is change the signs. So this is positive and this is positive, so we change them both to negative. So this becomes a negative and this becomes a negative. So 3x minus 3x is 0. So 3x take 3x is 0. 6 take away 6 is also 0. So if you end up with 0 at the end, you know that you're gone right. So the answer there is x plus 3, what you have on the top. So we'll do another example of that because I know there are a lot of steps in it, but you do each of these the exact same way. So we'll go on to example 2. And the question is to divide x cubed plus 6x squared plus 11x plus 6 by x plus 3 using long division. So there's an x cubed term this time, but we're still going to do it the same way. So let's write it out properly. X plus 3 into x cubed plus 6x squared plus 11x plus 6. So we're going to do this the exact same way. X into x cubed. So again, if you're not sure, x cubed is x by x by x, and you're dividing it by x. So they cancel, and what you're left with is x by x, which is x squared. So that's what goes up here. Then what you're going to do is multiply x by x squared and 3 by x squared. So x by x squared gives you x cubed, which is what you want. And 3 by x squared gives you 3x cubed. Sorry, 3x squared should I say. It's 3x squared. Now remember we changed the signs, so that becomes minus and that becomes minus, which enables you to cancel these out. So then 6x squared take 3x squared is 3x squared. What you're going to do now is bring down the 11x. And we're going to go again. X into 3x squared. Let's test it out over here. So 3x squared. So it's 3 by x divided by x. The x's cancel and you're left with 3x. So that goes up here. Then what we're going to do is we're going to multiply x by 3x and 3 by 3x. So x by 3x gives you 3x squared. And 3 by 3x gives you 9x. Same idea, we change the signs, so that becomes negative, and this becomes negative. So the 3x squareds cancel because 3x squared take away 3x squared is 0. And 11x take away 9x gives you 2x. So this is a little bit different because we have an extra component, so we bring down the 6 now. So you're left with 2x plus 6. So we need to go again. X into 2x goes twice, and I'll just show you over here. So 2x divided by x, they cancel, so it's twice. So you put plus 2 over here. So then again, we're multiplying x by 2 and 3 by 2. So x by 2 gives you 2x, and 3 by 2 gives you 6. We change the signs, this becomes negative, and this becomes negative, and you're left with 0. Which means you have it right. So that's it for long division. There are a couple of steps in it, and I'm going to do some exam questions at the end of this just to make sure we're clear on it. So we're going to move on to the third section now. And the third section is surds and indices. Okay, with surds and indices, we're going to look at two laws. So the first law is law 1. And law 1, and you'll get this in your log table. So root A multiplied by root B is equal to the same as saying root AB. And law 2, which we're looking at, is the root of A over the root of B is the same as saying the root of A over B. Now I'll put these into practice. So we're going to do some examples. So example 1. So simplify the following. Expressions using laws of surds. Okay, so the first one is root 3 multiplied by root 5. The second one is root 8. And the third one is root 7 over root 5. So we're going to answer all of these using the laws of surds. So this one here, root 3 by root 5. So if root A by root B is the same as saying the root of A by B. So we can rewrite this. So root 3 multiplied by root 5 is the same as saying root of 3 by 5. The root of 3 by 5 gives you root 15, and that's the answer. The second one, root 8. So can we simplify this? The way we do this is, see, can we split it into its factors, and it will simplify then. So root 8, if we wrote that as root 4 by 2, because 4 by 2 gives you 8, that's the same as saying root 4 by root 2. The root of 4 gives you 2, so it's 2 multiplied by root 2. The answer is 2 root 2. So that's it simplified. The third one, root 7 over root 5. So this is this law here. So root 7 over root 5. So root A over root B is the same as saying the root of A over B. So if we were to rewrite that, it would be the same as saying the root of 7 over 5. And we can't simplify that anymore. I'm going to do example 2 on the next slide now, which is more examples of using laws of surds. So we're going to go on to example 2 now. So the question is to simplify the following expressions using the laws of surds. so the first one there is root 15 by root 20. The second one is root 40 over root 8. And the third one is root 75 over root 50. So I'm just going to actually write out the two laws as well. And again, these are in your log table. So law 1 is root A root B is the same as saying the root of A by B. And law 2, so root A over root B is the same as saying the root of A over B. So let's look at the first one. So you have root 15 by root 20. So can we write this in better terms, or write it using one of the laws? So root 15 by root 20 is the same as saying root 15 by 20. Now if you multiply 15 by 20 on your calculator, you'll get root 300. The root of 300 we can rewrite as the root of 3 by 100. We can then rewrite that as root 3 by root 100. And you will find that you will be able to get the square root of 100, because the square root of 100 is 10. So it's root 3 by 10. And we rewrite that, as 10 root 3. So the idea is, when you get questions like this, you want to see, can you get a root of a number that will give you a whole number? So root 100, root of 81, root of 64, they will all give you a whole number. So that's the idea. So let's go on to number 2. So you have root 40 over root 8 is the same as saying the root of 40 over 8. So that's using the law. 40 divided by 8 is 5. So if you actually divide 40 by 8, it works out, so you get root 5. And that's the answer to question 2. Then for question 3, root 75 over root 50 is the same as saying root of 75 over 50. If you divide 75 by 50, so 25 will go into both of those, so you can simplify it. So it's 25 into 75 goes 3 times, 75 into 50 goes twice, so it's the root of 3 over 2. And that's it. So I have one more example to do on thirds, and it's to do with if we have the same square root, we can actually add or subtract them. So I'll do an example on that now on the next slide. So we're going to move on to example 3 now, and that's a different type of question again, where you have the same third. So we'll go on to example 3 here. And the question is to simplify the following. Simplify the following expressions. Using the laws of thirds. So the first one is going to be root 3 plus root 3. The second one is root 3 plus root 12. And the third one is root 45 minus root 20. So with these ones, so we'll look at example, or the first one there from example 3. So root 3 plus root 3. So you can see that they're the same because it's root 3 plus root 3. So that's like saying 1 root 3 plus 1 root 3 is going to give you 2 root 3. Because you're adding root 3, or 1 root 3 plus 1 root 3, and that will give you 2 root 3. So that's a pretty straightforward one. So then we're going on to the second example. So we've root 3 plus root 12. So let's try and break this down a little bit. So root 3 we have to leave. Can we put root 12 in another format? Well, we can put it as root 4 by 3 will give you 12. So root 4 by 3. So that's going to give us root 3 plus root 4 root 3. Now here you will see that, so you get root 3 there. Root 4 gives you 2, so it's going to be 2 root 3. And that's saying 1 root 3 plus 2 root 3. So 1 root 3 plus 2 root 3 gives you 3 root 3. And that's the answer to question 2. So for question 3 then, we're going to do the same thing again. We're going to try and break it down. So root 45. So we can rewrite root 45 as root 9 by root 5 minus. See, can we get root 20 in terms of root 5? We can. So root 4 by root 5. Root 9 gives us 3, so it's 3 root 5 minus root 4 by root 5 gives us 2 root 5. Because root of 4 is 2 and the root of 9 is 3. Now what we have is 3 root 5 take away 2 root 5. So 3 take away 2 is 1. So it's going to be 1 root 5. And that's the answer to the last one. Now you can also rewrite 1 root 5 as just root 5. So that's the answer to the third example there. So we're going to move on to some exam questions based on those 3 sections now. Okay, so we're going to look at an exam question now, and this is from a higher level paper. So a capacitor is a device which stores electricity. The formula W is equal to half CV squared gives the energy stored in the capacitor, where W is the energy, C is the capacitance, and V is the voltage. And the standard units are used throughout. So find the amount of energy stored in a capacitor when C is 2500 and V is 32. So our formula is W is equal to a half CV squared. So we are given values for C and we're given values for V. So we're just going to plug them in. So W is equal to a half C, which is 2500, and V is 32. And we're going to square that. So you literally plug that straight into the calculator and you're going to get 1,280,000. And that's the answer for that one. So part B of this question is going to be done on the next slide. So now it says to write V in terms of W and C. So the formula that we have is W is equal to a half CV squared. So we need to isolate V on its own. So what we would do here is get rid of the half and then get rid of the C and then just get V squared on its own first of all. So we need to bring the half over to this side of the equation. So it's a half, so it's actually going to flip over. So it's divided by 2 on this side. So when we bring it over, it's going to multiply. So it's going to be 2W is equal to CV squared. So now what we need to do is bring C over this side as well. So C, it's going to become 2W divided by C is equal to V squared. So I'm just going to switch it around here for it to be V squared is equal to 2W over C because I want to get V on its own. So we want to get V on its own, so we need to get rid of the squared term. So when you bring it over the other side, I'm just going to do it up here, it's going to be V is equal to the root of 2W over C. And that's the answer to the second part. So V is equal to the root of 2W over C. So I'm going to move on to another exam question now on the next slide. So this is a long division question. So divide x cubed plus 5x squared minus 29x minus 105 by x plus 3. So we're going to write it out properly. So x plus 3 into x cubed plus 5x squared minus 29x minus 105. So what we need to do first is divide x into x cubed. So x cubed is x by x by x divided by x. So they cancel and we're left with x squared. So that's what's going to go up here. So x multiplied by x squared and then 3 by x squared. So x by x squared gives us x cubed. And then 3 by x squared gives us 3x squared. Now remember we changed the signs, so this is going to become negative and this is going to become negative. So we can get rid of the x cubes. 5x squared take away 3x squared gives you 2x squared. Now we're going to bring down the minus 29x and we're going to start again. So this time we're going to divide x into 2x squared. So 2x squared is 2 by x divided by x. So we get rid of them and we're left with 2x. So that's what we're going to put on top. So it goes plus 2x. So then what we're going to do is the same as before. We're multiplying x by 2x and 3 by 2x. So x by 2x gives you 2x squared. And 3 by 2x gives you 6x. And remember, we change the sign. So this becomes minus, and this becomes minus. So we can get rid of the x squareds. Minus 29x minus 6x will give you minus 35x. And we're going to bring down the last number, so minus 105. And the last thing then, x into minus 35x. So minus 35x divided by x. They cancel, you're left with minus 35. So that goes up here. So the last thing then we need to do is multiply x by minus 35, which gives you minus 35x. And 3 by minus 35, which gives you minus 105. And the last thing we do is change the signs. So that becomes positive, and that also becomes positive. You end up with 0. If you end up with 0 at the end, you know that you're correct. So the answer there is x squared plus 2x minus 35. So I'm going to paste some useful links into the chat, so some extra videos and other exam questions that you can attempt also. And I will speak to you next week.